What if I told you one of the most powerful AI models right now is not the biggest, not the most expensive, and not locked behind a giant paywall? This is Gemma 4, and under the hood, it is doing something very different. Gemma 4 is part of a new wave of compact, high-efficiency language models designed to run closer to the edge. That means faster responses, lower cost, and way more control for developers. But to really understand why that matters, we have to break down how it actually works. At its core, Gemma 4 is built on the transformer architecture, same foundational idea that powers most modern large language models. But what makes Gemma different is not just the architecture, it is how that architecture is optimized. Let's start with scale. Traditional models chase size, more parameters, more data, more compute. Gemma 4 takes a different approach. It focuses on efficiency per parameter. That means every layer, every attention head, every token prediction is tuned to extract more value from less compute. Under the hood, Gemma 4 uses highly optimized attention mechanisms. Attention is what allows the model to understand relationships between words. Instead of processing text linearly, it builds a weighted map of context. Who relates to what matters most, what can be ignored. In older models, attention becomes expensive fast, quadratic scaling. More tokens means exponentially more compute. Gemma 4 introduces optimizations that reduce this overhead. Smarter attention routing, better token prioritization, less wasted computation. Now let's talk about tokenization. This is where raw text becomes machine-readable. Gemma 4 uses a refined tokenizer that balances vocabulary size with flexibility. Too small and you lose nuance, too large and you waste memory. Gemma hits that middle ground where it can represent complex language efficiently without bloating the model. Next layer, training. This is where most of the magic happens. Gemma 4 is trained on a curated dataset designed to maximize signal over noise. Instead of just throwing massive amounts of raw internet data at the model, the training process filters for quality. That means better reasoning, cleaner outputs, and fewer hallucinations. It also uses instruction tuning. This is critical. Raw models predict text. Instruction-tuned models follow intent. That means when you ask a question, the model is not just guessing the next word. It is aligning with the task you are trying to complete. And then there is fine-tuning. Gemma 4 is designed to be adaptable. You can take the base model and specialize it, whether that is coding, writing, data analysis, or system design. The architecture supports efficient fine-tuning without needing massive infrastructure. Now let's talk about inference. This is where the model actually runs. Gemma 4 is optimized for low-latency environments. That means it can run on smaller hardware, even local machines. That changes everything. Instead of sending every request to a remote server, you can process data closer to the source. Lower latency, better privacy, reduced cost. And this is where things start to get interesting for front-end systems. Imagine integrating Gemma 4 directly into your application stack, not as an API call, but as a local or edge component. That means your UI is no longer just rendering data, it is thinking in real time. Dynamic interfaces, adaptive typography, context-aware interactions. This is where systems like FVLA start to make sense, because once intelligence moves closer to the interface, typography is no longer static. It becomes responsive to meaning, to context, to user intent. Now let's go deeper into architecture decisions. Gemma 4 likely incorporates improvements in normalization layers and activation functions. These are small details that have massive impact. Better normalization means more stable training. Better activations mean more expressive representations. It also benefits from advances in quantization. This is huge. Quantization reduces the precision of the model weights. Instead of 32-bit floating point, you might use 16-bit or even 8-bit. That cuts memory usage dramatically while maintaining performance. Gemma 4 is designed to work well under these constraints, so now you have a model that is smaller, faster, and cheaper to run, but still capable of high-quality output. That is the shift, not just bigger models, smarter models. Another key piece is alignment. Modern models are not just trained to predict text, they are trained to behave. That includes safety layers, response shaping, and guardrails. Gemma 4 includes alignment techniques that make it usable in real-world applications without constant supervision. Now let's talk about performance. In many benchmarks, models like Gemma 4 punch above their weight class. That means they compete with larger models in specific tasks, especially when fine-tuned. Why does this happen? Because performance is not just about size, it is about how well the model uses its capacity. A well-optimized smaller model can outperform a poorly optimized larger one, and that is exactly what we are seeing. Now bring this back to development workflows. If you are building modern web systems, Gemma 4 opens new doors. You can embed intelligence directly into your pipeline, code generation, debugging, content creation, user interaction.
All happening closer to your stack. This reduces dependency on external services. It gives you more control over latency and cost. And it allows for deeper integration with your own systems. Now let's connect this to the future. We are moving toward distributed intelligence. Not one giant model in the cloud, but many specialized models working together. Some local, some remote, some embedded directly into applications. Gemma 4 fits perfectly into that world. It is not trying to be everything. It is trying to be efficient, adaptable, and deployable. And that is a very different philosophy. So when you hear about Gemma 4, do not think of it as just another model release. Think of it as a signal, a shift from scale to efficiency. From centralized to distributed. From static systems to intelligent interfaces. Because under the hood, that is what is really happening. The stack is changing. The way we build is changing. And the interface is becoming alive. Thanks for watching Front End Systems Lab. Please subscribe for more under the hood content.